In this video we'll look at transition matrices. Now a transition matrix is used to look at what happens over a period of time, so it could be on a daily, weekly, monthly or even yearly basis. And we let T be the transition matrix. Now the problem we will use as an example is looking at the buying trends of ice cream customers, and we'll analyse that over a weekly basis. So the state matrix is the beginning situation. So S will be the starting state. So S0, so subscript 0, is the initial state matrix. And in this case, we know that brand Ace makes ice cream, and 63% market share is what they control. And therefore other brands must be therefore 37%. So our initial state matrix, S0, we would have 63% for the brand Ace, and then 37% for the other brands. Now Ace have done some work and found out that if someone buys Ace one week, there's an 80% chance they'll buy Ace in the second week. So buying now, we have Ace, 80% chance buying next week. And they've also discovered that of those who buy another brand in the first week, there's a 30% chance they'll buy Ace in the second week. So if customers who buy Ace this week have an 80% chance of buying Ace, they must have a 20% chance of buying the other brand in the following week. And likewise, if you don't buy Ace in the first week, 30% chance of buying it next week, that must mean a 70% chance that it won't be bought on the second week. So this constitutes our transition matrix. So the entries tell us how the market varies from week to week, and that's why it's called a transition from one period of time to another. So after 1 week, the proportion of people who will be buying Ace will be 80% of the initial 63% market share, and then a further 30% of the 37% who didn't buy Ace in the first week. So we would multiply 0.8 by 0.63, etc., add those together, and we end up with 61.5% with Ace and 38.5% with the other brands. Now if we were to multiply S0, that's our starting state, by the transition matrix, we have 1 row 2 columns and 2 rows 2 columns. We end up with a 1 by 2. So we'd have the first element is first row times first column, which gives us this calculation here. And this element is the first row second column, so first row second column, we end up with 0.385. So that confirms that after 1 week, the market share for Ace is now 61.5%, our value here, and other brands 38.5%. So we've dropped from a starting value of 63% down to 61.5%, and the other brands 37, now bumped up to 38.5%. So this matrix will show the conditions or the state after one transition, after 1 week. If we were to work it out over a period of time, then we'd have S2 would be the previous state multiplied by the transition, and so on and so forth. So each time we would multiply by the state matrix and the transition matrix. So to work out the situation week by week, we would multiply the transition matrix by the previous state. So here we have S1, so S2, S3, and if we look at the values that we get as we progress from week to week, we can see that these values are pretty much the same. So it looks like the market share for Ace has been fixed at about 60%, and the other brands about 40%. So there's little change between S4 and S5. Proportions are converging to 60 and 40%. So when we see over a period of time little changes occurring, this situation is known as the steady state. So when S of n plus 1, so that's 1 week, 1 period of time's value, is about the same as the previous value, then we have reached a steady state. Which would therefore mean if we were to want to work out the steady state, what the limit will be, we would just multiply 1 week by the transition matrix for a period of weeks, and that would eventually give us a particular steady state. But we can achieve this another way. So if we looked at the transition matrix T, and here it is here, if we were to square it, then square that, and so on, then we eventually end up with a matrix where we have our 60% and 40%, which was the market share for ACE and the market share for other brands. So we end up with the steady state proportions. And as it says here, most importantly, this steady state system can be found irrespective of the original situation. So there are two ways to determine the steady state. Either continue multiplying 1 week by the transition matrix until such a point where you don't get any change, or by work out t to the power of n, the transition matrix, to a large power, and that will give us the steady state as well. Now, if you're actually asked to work out the value at any particular period of time, then we've seen this before. So S2 would be the previous value multiplied by t, S3 previous value multiplied by t, but as we can see here, we can actually express it in terms of the original state, and so that state matrix multiplied by t to the power of 4 would give us the value at 4 weeks or 4 periods of time. So in general terms, S of n would be the original state matrix multiplied by t to the power of whatever time period we're looking at. Now there is another way to work out the steady state using algebra. Now if the steady state is AB, we know that if we multiply AB by the transition matrix, it won't change. So therefore, AB times by the transition matrix is still AB. So if we multiply these pair of matrices, we end up with this one here, and if we equate terms, we get these equations, which when solved will in fact give us the value of A of 0.6 and the value of B of 0.4.